Hello there, and welcome to The Sleepy Scientist. Tonight we travel outward beyond the familiar planets, beyond the last bright edges of our solar system, and into one of the quietest places we can imagine. We drift gently toward the Oort Cloud, a distant icy region that surrounds our sun like a soft, invisible halo, where time stretches wide and motion becomes almost still. Before we begin, allow yourself to settle comfortably. Let your shoulders drop, your hands relax, and your breathing slow without effort. There is nothing you need to focus on, and nowhere you need to go. Whatever belonged to the day can fade softly into the background, becoming quieter with each calm breath you take. The Oort Cloud is not a place of sudden events or sharp changes. It is a place of deep distance, faint light, and patient cold. Far from the warmth of the sun, countless icy bodies drift slowly in the darkness, held by gravity so gently that even the smallest influence can guide them over millions of years. Everything here feels quiet, preserved, and unhurried. As we continue, we'll explore the most relaxing facts about the Oort Cloud. We'll observe what it may be made of, how it might have formed, and how it quietly shapes the long journey of comets through space. These facts are not meant to excite or overwhelm. They are meant to slow your thoughts, soften your attention, and guide you gently toward rest. If you enjoy these calm journeys through the gentle side of science, you're always welcome to subscribe and return whenever you need quiet curiosity or peaceful sleep. But for now, allow your awareness to drift outward, far beyond the planets, into the faint icy stillness of the Oort Cloud. Let's begin. The Oort Cloud is often described as a vast, quiet halo surrounding our solar system, and the most calming part of it is the scale of time it represents. If you could drift outward far beyond the last planet, beyond the Kuiper Belt and out into the dim edge of our sun's reach, you would find a region where motion is so slow that change feels almost imaginary. Objects there can take millions of years to complete gentle journeys, and the environment feels like a place where the solar system keeps its oldest, most patient memories. The Oort Cloud is not a solid ring or a bright band in the sky, but a deep three-dimensional region that surrounds the solar system in every direction. Unlike the flat plane where most planets orbit, the Oort Cloud is imagined as a distant sphere, meaning it extends above and below the solar system's main disk. This shape makes it feel like a soft, quiet shell, a gentle boundary where icy objects drift in long, slow arcs, held loosely by the sun's far-reaching gravity. Even though we cannot photograph the Oort Cloud directly in the way we can image planets, it still holds a strong place in scientific understanding because it helps explain where long-period comets come from. These comets arrive at the inner solar system from faraway angles, sometimes appearing unexpectedly, and their paths suggest a distant reservoir of icy bodies. The idea is calming because it implies that far beyond the familiar planets, there is a quiet population of objects waiting for eons, only occasionally beginning a slow inward drift. The distances involved in the Oort Cloud are so immense that the sun would look like an unusually bright star rather than a blazing disk. At those ranges, sunlight is faint, gentle and cold, more like a soft glow than a source of warmth. This means the Oort Cloud is naturally suited to quiet preservation. Ice can remain stable for extraordinary spans of time, and surfaces may change so slowly that they become almost timeless, shaped by the smallest, rarest interactions. The objects that make up the Oort Cloud are believed to be mostly icy bodies, similar in composition to comets, containing frozen water, methane, ammonia, and other volatile compounds. In the deep cold of that distant space, these materials remain locked in place, not evaporating quickly, not cycling through seasons, simply resting. This steady frozen calm gives the Oort Cloud a peaceful personality, like a distant storage of the solar system's earliest ingredients, kept safe by low light and extreme quiet. One of the most soothing ideas about the Oort Cloud is how loosely it is bound to the sun. Gravity still reaches that far, but its pull becomes gentle and delicate, like a quiet thread rather than a firm grip. Objects in the Oort cloud drift slowly, and small influences can matter. Passing stars, faint galactic tides, and distant gravitational nudges can subtly reshape their paths over millions of years, guiding them without urgency, allowing motion to remain soft and gradual. The Oort cloud may begin thousands of astronomical units away from the Sun and extend outward for tens of thousands, perhaps even up to 100,000 astronomical units in its farthest reaches. An astronomical unit is the average distance between Earth and the Sun, so even the inner edge of the Oort cloud is unimaginably distant compared to the orbits of the planets. This enormous scale creates a sense of spaciousness that feels almost endless, a region where the solar system fades gently into interstellar space. In the Oort cloud, the night sky would look different from what we know, not because stars disappear, but because the familiar structure of the solar system would no longer dominate. The planets would be far behind you, too dim and distant to matter, and the Sun would be just one bright point among countless others. In that environment, the galaxy itself would feel more present, a wide background of stars and faint cosmic light, offering a calm reminder that even our solar system is only a small part of something much larger. Long-period comets, the ones that take thousands or even millions of years to return, are connected to the Oort cloud in a way that feels almost like slow breathing. Most of the time, these objects remain far away, sleeping quietly in the cold. But once in a very long while, gravity and distant influences may guide one inward. The journey is not sudden. It begins gently, gradually, and the comet spends years, decades, or centuries moving closer, as though it is taking its time to return to the light. The Oort cloud represents a peaceful boundary between what belongs to the Sun and what belongs to the wider galaxy. It is not a sharp border, but a fading edge, where the Sun's influence becomes quiet enough that interstellar space begins to feel close. This makes the Oort cloud a calming concept, because it reminds us that the solar system does not end with a wall or a dramatic line. It ends softly, gradually, with distance increasing and light fading, until the universe beyond becomes the gentle, natural continuation of everything. The Oort cloud is thought to be so distant that even the concept of far away begins to feel gentle and meaningless. Out there, distance is not something you cross quickly, it is something you slowly exist within. If you imagine travelling beyond Neptune, past the Kuiper Belt and further still, you would eventually reach a place where the solar system becomes less like a neighbourhood and more like a quiet memory, and where the Sun's influence continues only as a soft, patient presence. One of the most calming scientific ideas about the Oort cloud is that it may contain objects that have remained almost unchanged since the earliest days of our solar system. In the beginning, when the Sun and planets were forming from a swirling disk of gas and dust, countless icy bodies were scattered outward. Some were pushed gently away by the gravity of the giant planets, flung into distant space not with violence but with gradual gravitational guidance. Over time, these objects may have settled into the Oort cloud, becoming quiet, frozen archives of the solar system's first materials. In such a cold, distant environment, temperature does not fluctuate the way it does closer to the Sun. There are no warm summers or bright days to soften the surface. Instead, the cold remains constant, and that steady cold helps preserve icy compounds for unimaginable spans of time. It creates an atmosphere where molecules can rest in stable forms, where surfaces change slowly, and where time itself seems to move at a slower pace because nothing forces rapid transformation. The Oort cloud is often described as a reservoir of comets, but what makes that idea soothing is how rarely these objects actually travel inward. Most of the time, they remain where they are, drifting in long, faint orbits that take hundreds of thousands or millions of years to complete. Their existence is mostly quiet and still. When one comet finally begins its slow inward journey, it does not rush. It drifts inward patiently, guided by gravity over long eras, as though taking its time to return. The shape of the Oort cloud is believed to be more spherical than the disc-like shape of the rest of the solar system. This means that comets from the Oort cloud can approach the inner solar system from almost any direction, not just along the plane where the planets orbit. This spherical form creates the impression of a soft shell around the Sun, like a faraway, quiet boundary where objects float above and below the familiar orbital paths, existing in a calm three-dimensional openness. One gentle influence on the Oort cloud comes from something called galactic tides. Just as the Moon's gravity creates tides in Earth's oceans, the larger mass of the Milky Way can create a slow, subtle tide-like influence on objects far from the Sun. This does not happen quickly, and it does not cause dramatic motion. Instead, it gently nudges distant objects over millions of years, slowly reshaping their orbits in ways that are almost too subtle to notice, yet steady and persistent, like a quiet background rhythm. Another calm influence on Oort cloud objects can come from passing stars. The Milky Way is full of stars moving in their own orbits, and occasionally one may pass relatively close to our solar system. Even then, close still means far beyond the planets, far into deep space. When such a star passes, its gravity can gently tug on some Oort cloud objects, shifting their paths slightly. This interaction is not like an impact, it is more like a soft gravitational whisper, nudging a few distant bodies into new, slow trajectories. The Oort cloud's objects are believed to be small compared to planets, but their number may be vast. Scientists estimate there could be billions or even trillions of icy bodies out there. What makes this comforting is that it suggests our solar system is surrounded by a quiet population of frozen travellers, each one drifting slowly in darkness, each one part of a larger structure that feels calm and protective, like a distant halo beyond the noise of the inner worlds. Because the Oort cloud is so far away, the sunlight reaching it is extremely faint. The sun would no longer cast strong shadows or create bright highlights. Instead, light would be soft and minimal, barely enough to illuminate surfaces. This creates a visual atmosphere that feels muted and restful. Darkness becomes gentle rather than harsh, and the faint starlight of the galaxy becomes more noticeable, filling the sky with calm points of light. One of the most peaceful aspects of the Oort cloud is how it represents a gradual transition from our solar system into interstellar space. There is no wall, no boundary line, no sudden change. The Oort cloud fades outward, becoming less dense, less influenced by the sun, until it blends into the wider galaxy. This reminds us that the universe often ends things softly, not with dramatic edges, but with gentle distance, where belonging slowly becomes openness, and the familiar turns quietly into the vast. The deeper you imagine drifting into the Oort cloud, the more it begins to feel like a region made of quiet distance rather than objects. Space is so wide and the icy bodies are spread so far apart that even if there are trillions of them, the emptiness between them remains enormous. This creates a calming sense of openness, where nothing crowds anything else, and where the solar system feels as if it has expanded into a gentle, spacious silence. One of the most soothing scientific details about the Oort cloud is that an object there may spend most of its existence in darkness so complete that it becomes a steady companion. Without strong sunlight, without warming cycles, and without energetic activity, surfaces can remain unchanged for incredibly long periods. If an icy body has a layer of frozen water or methane on its surface, that layer can stay preserved as though time itself has chosen to move around it rather than through it. The Oort cloud helps explain why some comets appear to be visitors from a far distant neighbourhood. Long-period comets often have orbits that tilt at unusual angles compared to the planets, suggesting they came from a spherical region rather than the flat disk of the solar system. This means the Oort cloud is like a quiet reservoir surrounding us, where comets rest in slow motion for eons until a gentle gravitational nudge invites one of them to begin its long inward drift. Comets from the Oort cloud do not arrive quickly. Even once their orbits are disturbed, they may take thousands of years to travel inward toward the sun. Their journey is not dramatic or sudden. It is slow and patient, guided by a steady pull that grows slightly stronger as they approach. This long travel time adds to the calmness of the idea, because the solar system is not being visited by rushing objects, but by travellers moving slowly through deep time. A comforting way to imagine the Oort Cloud is as the solar system's quiet outer library, holding small icy bodies that contain chemical information from the early solar nebula. When the planets were forming, material was mixed and scattered, but some of that material may have been gently placed into long-term storage far away. These objects could still carry traces of the original compounds that were present when the sun first began shining, making them calm archives of the solar system's earliest beginnings. Because the Oort Cloud exists at such extreme distances, it sits in a region where the sun's gravity is gentle enough that other influences become noticeable. The overall mass distribution of the Milky Way can softly reshape the orbits of distant objects over millions of years. This influence does not feel harsh or forceful. It feels like a slow tide, a steady cosmic background that touches the Oort Cloud lightly, reminding us that even the outermost parts of our solar system remain connected to the larger galaxy. Scientists sometimes describe the Oort Cloud as having an inner part and an outer part, though these boundaries are not sharp. The inner region may be more strongly bound to the Sun, while the outer region may blend more easily into interstellar space. This gradual structure is calming because it reflects how nature often prefers soft transitions rather than hard lines. The Oort Cloud does not end suddenly, it fades gently, step by step into the wider universe. The environment of the Oort Cloud is so cold that most physical processes slow down dramatically. Chemical reactions become rare. Surfaces do not melt or evaporate quickly. Even impacts, when they occur, are infrequent. This creates a setting where stability is the dominant feature, and where the passage of time feels smooth because nothing forces rapid changes. If you could look outward from within the Oort Cloud, the sky would feel full of the distant stars, and the Milky Way might appear as a steady luminous band. But if you looked inward, the sun would be only a bright star among many, though still the brightest. This change in perspective is calming because it shifts the solar system from being the centre of everything to being one gentle light in a wide, quiet galaxy. The Oort Cloud also reminds us that much of the universe exists in a state of quiet waiting. Not everything is active or constantly changing. Some regions simply hold matter in place for long periods, preserving it, protecting it, and allowing it to remain calm. In this way, the Oort Cloud is not just a distant collection of icy bodies, it is a symbol of patience in the solar system, a place where distance and time create a natural stillness that continues without urgency. When you imagine the Oort Cloud, one of the most restful things to remember is that it is not crowded, even if it may contain an enormous number of objects. Each icy body is separated from the next by such vast distances that the space between them remains the dominant feature. This creates an environment where the idea of neighbourhood becomes soft and wide, and where stillness feels natural because there is nothing nearby to disturb it. Many of the objects in the Oort Cloud are thought to be small and dark, reflecting very little light. Their surfaces may be coated with ancient radiation-darkened materials, built up slowly over time. This darkness is not threatening. It is gentle, like a calm fabric wrapped around the outer solar system, reducing brightness, softening contrasts, and allowing the region to exist in quiet visual simplicity. A peaceful scientific detail is that the Oort Cloud's objects likely move on orbits that are extremely large and slow. Some may take hundreds of thousands or even millions of years to complete a single orbit around the Sun. This means that motion there is not something you watch unfold. It is something you understand as a quiet background truth, like the slow turning of a clock that measures time in eras instead of hours. The forces shaping these distant orbits are subtle. The Sun's pull is still present, but it is so gentle that passing stars or the broad gravitational field of the galaxy can influence trajectories. These influences do not cause sudden change. Instead, they act like small nudges that slowly reshape paths over immense spans of time, allowing the entire region to feel guided by patience rather than urgency. Scientists believe the Oort Cloud may have formed when the giant planets were still settling into place early in the solar system's history. Jupiter, Saturn, Uranus and Neptune could have scattered icy bodies outward as they moved and interacted. Many of these bodies may have been ejected entirely into interstellar space, but some may have remained loosely bound and gradually settled into the distant reservoir we call the Oort Cloud. This origin story is calming because it suggests the Oort Cloud is not random. It is the quiet result of gentle gravitational rearrangement. Because we cannot directly image the Oort Cloud, its existence is inferred through patterns in comet orbits. This is a peaceful kind of science, built on patient observation, long-term measurement, and careful reasoning. It reflects the way astronomy often works, not through sudden discoveries, but through slow understanding, where the universe reveals its structure gradually through patterns and quiet clues. The Oort Cloud likely contains objects with a wide variety of compositions. Some may be rich in water ice, while others may hold frozen carbon dioxide, methane, ammonia, and complex organic molecules. In the deep cold of the outer solar system, these compounds remain stable for incredibly long periods, preserving their chemistry like a quiet archive. This stability makes the Oort Cloud feel like a gentle chemical library, storing the solar system's original ingredients in a frozen state. Another calm detail is that the Oort Cloud represents a region where sunlight is no longer the main shaping force. Closer to the sun, sunlight drives weather on planets, melts ice, and powers activity. In the Oort Cloud, sunlight becomes faint and delicate, so the usual energetic processes fall away. What remains is a calm form of existence where temperature and surface conditions remain steady and quiet. The Oort Cloud can also be seen as a kind of protective buffer around the solar system. While comets can sometimes travel inward and become visible, most remain far away, acting like a distant shell of icy material. This does not mean the Oort Cloud is a shield in a literal sense, but it does create the feeling that the solar system has an outer layer, a quiet boundary where matter drifts patiently rather than moving chaotically. Perhaps the most soothing way to think about the Oort Cloud is as a place where time is stored in distance. The farther outward you go, the longer everything lasts. Motion slows, change becomes rare, surfaces preserve their past. In this way, the Oort Cloud is not just the edge of our solar system's gravity, it is the calmest expression of the solar system's patience, where everything continues quietly, unchanged, and unhurried for eons. One of the most peaceful truths about the Oort Cloud is that it likely exists in a realm where the sun's warmth has almost no authority. The sunlight that reaches those distances is so faint that it feels more like a distant memory of light than an active presence. This means the Oort Cloud lives in a steady cold where the environment does not shift with time of day, season, or planetary alignment. It remains quiet and consistent, as though the solar system has gently faded into stillness. The Oort Cloud is often imagined as a distant sphere surrounding the sun, but the calmest part of that image is how it suggests wholeness. The planets travel mostly in a flat plane, like beads on a disk, but the Oort Cloud surrounds everything above and below in every direction. It feels like a soft boundary that holds the solar system inside it, not as a wall, but as a quiet, distant presence that marks where belonging slowly transitions into open space. Because objects in the Oort Cloud are spread so far apart, collisions there would be extremely rare. Even with trillions of bodies, the distances between them remain vast enough that most will never come near another object for their entire existence. This rarity of impact creates an environment where stability dominates, surfaces can remain undisturbed, histories can remain intact, and time can pass without leaving sudden marks. Some scientists suggest the Oort Cloud may contain objects that were once closer to the Sun, formed in regions where ice and rock mixed differently before being scattered outward. If this is true, then the Oort Cloud is not only a collection of distant bodies, but also a record of early solar system mixing. This idea feels soothing because it suggests the outermost region holds memories of many inner regions, preserved quietly by cold and distance. The quiet influence of passing stars is one of the gentlest processes affecting the Oort Cloud. A star may pass close enough, in cosmic terms, to slightly shift the orbit of an icy body, but even this close pass occurs over huge distances and long durations. The passing star does not arrive suddenly. It drifts through space on its own path, offering a slow gravitational nudge that unfolds over thousands or millions of years, like a soft touch that never becomes an impact. Galactic tides also act on the Oort Cloud in a way that feels like slow breathing. The Milky Way's mass distribution creates a gentle gravitational pull that slowly reshapes distant orbits. This pull is subtle and constant, never dramatic, never sudden. Over immense spans of time, it can guide some objects into slightly different trajectories, as though the galaxy is quietly reminding the solar system that it exists within a larger structure. A calming detail about Oort Cloud comets is that they often begin their inward journeys without any visible sign. An orbit may slowly change for millions of years before the comet finally reaches a point where it drifts inward more noticeably. Even then, the journey takes a long time. The comet remains a quiet traveller for most of its path, only becoming bright and active when it finally approaches the warmth of the inner solar system. At the distances of the Oort Cloud, the sky is dominated by the wider universe rather than the Sun. The Milky Way becomes more visually prominent, and the Sun becomes only one bright star among many. This change in perspective is calming because it removes the feeling of being centered on one object. It reminds us that our solar system is part of a larger calm pattern, one thread in a vast cosmic fabric that stretches far beyond familiar orbits. The Oort Cloud also represents how boundaries in the universe are rarely sharp. There is no clear moment where the solar system ends and interstellar space begins. Instead, the Oort Cloud fades outward gradually, becoming less dense, less bound, more open. This gentle fading creates a peaceful sense of transition, where the universe does not end with an edge, but with a soft blending into the larger space beyond. Perhaps the most restful way to think about the Oort Cloud is as a region that invites slow imagination. It is distant enough that it cannot be rushed, quiet enough that it cannot be forced into urgency, and vast enough that it feels like a calm ocean of space. Objects there drift patiently, preserved by cold, guided gently by gravity, and surrounded by darkness that feels steady and peaceful rather than empty. One calming way to understand the Oort Cloud is to think of it as the Sun's most distant companionship, a region where gravity still reaches, but only softly. At those far distances, the Sun is no longer a commanding presence that shapes activity and change. Instead, it becomes a gentle anchor, holding countless icy bodies loosely, allowing them to drift without pressure, as though they are resting in an orbit that barely needs to be maintained. The Oort Cloud may contain objects that are so far away that their orbits are easily influenced by the quiet motion of our solar system around the Milky Way. As the Sun travels through the galaxy, its surrounding halo of distant icy bodies travels with it, like a soft, invisible envelope. This idea is soothing because it suggests our solar system is not just a set of planets, but a much larger moving presence, carrying a calm halo through space as it drifts along the galaxy's slow currents. Because the Oort Cloud is imagined as a sphere, it offers the possibility that comets can arrive from any direction, not just along the plane of the planets. This means that the solar system is surrounded quietly and evenly by potential cometary visitors. Yet most of these visitors never arrive. They remain far away in calm suspension, making the Oort Cloud feel less like a threat and more like a distant, quiet population waiting without urgency. The icy bodies of the Oort Cloud may rotate very slowly, and in such cold darkness their surfaces can remain unchanged for long periods. Without sunlight heating one side significantly more than the other, temperature differences are minimal. This creates a setting where rotation does not create cycles of warming and cooling. Everything stays calm, cold, and stable, allowing the object's surface to remain preserved like a quiet relic. If you imagine standing near an Oort Cloud object, the view would feel almost like floating in a deep ocean of space. The nearest neighbour object would likely be far beyond visibility, and the sun would appear as a bright star rather than a radiant disk. The sense of isolation would not feel sharp or empty, but wide and soothing, like being alone in a silent room so large that it becomes comfortable rather than lonely. The Oort Cloud is connected to one of the gentlest patterns in astronomy, the idea that small changes can take a long time to become unnoticeable. A comet's orbit may be nudged slightly by a passing star, shifting its trajectory by a fraction over millions of years. This quiet nudge can eventually guide the comet inward, but the process is so slow that it feels like the universe is making adjustments with care, never rushing, never forcing, always allowing time to do its work. Some models suggest the Oort Cloud may have been shaped over time as objects were gently raised into higher inclinations, becoming part of a spherical distribution rather than a disk. This is thought to happen through repeated small disturbances over long timescales. The calming part is the method. No sudden event is needed. The Oort Cloud can form from repeated gentle influences, like a shape created by countless soft touches rather than a single forceful change. The temperature in the Oort Cloud is expected to be only a few degrees above absolute zero, not because it is special, but because space itself is cold when far from starlight. In such a temperature range, energy is minimal. Molecular motion is slow, materials remain stable. This extreme cold creates a feeling of deep stillness, where the environment naturally favours preservation and quiet endurance. The Oort Cloud also reminds us that a solar system is not defined only by its bright, active inner worlds. It also includes distant, quiet regions where almost nothing happens, yet those regions still matter. They hold material, they influence cometary journeys, and they carry the outer structure of our sun's gravitational reach. This perspective is soothing because it shows that the solar system has peaceful outer layers, places where calm is the dominant theme. Perhaps the most restful fact is that the Oort Cloud may contain objects that will never be disturbed at all. Some may remain in slow, distant orbits for the entire lifetime of the sun. They will never drift inward, never glow brightly, never become visible to us. They will simply continue quietly and steadily, held gently by gravity and surrounded by cold darkness, existing as part of the solar system's farthest, calmest presence. One of the most peaceful ways to picture the Oort Cloud is as a region where the sun's gravity becomes almost like a soft whisper. It is still present, still holding distant icy bodies within a slow connection, but it no longer feels like a strong pull that defines every motion. Instead, it feels gentle and forgiving, allowing objects to drift in wide paths that change only gradually, as though the solar system is holding them with the lightest possible touch. The Oort Cloud also invites the idea that our solar system is a kind of quiet outer atmosphere, not made of air, but made of distant objects and empty space. While the planets are like the active inner rooms of a home, the Oort Cloud feels like the quiet outer garden that stretches far beyond sight, where time passes slowly and nothing demands attention. This scale creates comfort, because it suggests that even the sun has peaceful surroundings far from the energy of the inner worlds. If a long-period comet begins its journey inward from the Oort Cloud, it does not start with a sudden fall. It begins with a tiny change, perhaps caused by a passing star or a gentle galactic tide. The orbit shifts slightly, like a slow turning of a key in a distant lock. Over immense spans of time, this small adjustment allows the comet to drift toward the inner solar system, showing that even dramatic appearances in our sky can begin as the quietest possible motion in deep space. Because the Oort Cloud is so distant, it is also a region where the sun competes with the galaxy for influence. The Milky Way's gravity is not concentrated, but spread out, creating a steady background pull. Over time, this background influence can guide the slow reshaping of some orbits, gently changing angles and distances. This is a calming interaction because it shows that the solar system is not isolated. It is softly connected to the galaxy, and that connection expresses itself through patient, quiet gravitational guidance. The objects in the Oort cloud are thought to move through a space where collisions are not just rare, but almost unimaginable. Even if an object travels for millions of years, the chance of it striking another body is extremely low because of how spread out everything is. This makes the Oort cloud feel like one of the safest places for matter to remain unchanged, where surfaces can stay preserved and histories can remain undisturbed by impacts. In such deep cold, ice behaves differently than it would near the sun. It does not melt, evaporate or flow. Instead, it stays locked in place, forming a solid, stable surface that can endure for billions of years. This stability gives the Oort cloud a quiet strength, where the most common state is preservation rather than transformation, and where nothing rushes to become something else. The Oort cloud also holds a special place in our understanding of how the solar system evolved. It suggests that the early solar system was active and dynamic, but that activity eventually created distant quietness. Material was scattered outward, and over a long time it settled into a calm reservoir. This idea feels soothing because it shows that even energetic beginnings can lead to peaceful outcomes, where the final result is a distant region defined by stillness. Another gentle aspect of the Oort cloud is the way it changes our perspective on the sun. Closer in, the sun feels central and dominant, shaping everything. But in the Oort cloud, the sun becomes only one bright star in a wider cosmic sky. It still matters, but its dominance softens. This shift in perspective is calming because it reminds us that even familiar sources of power and light become gentler when viewed from far enough away. The idea of an inner Oort cloud, sometimes called the Hills cloud, adds another layer of quiet structure. This region may be more tightly bound to the sun than the outermost parts, serving as a deeper reservoir where objects are even less likely to be lost to interstellar space. It suggests that the Oort cloud may have layers, like a soft, distant nesting of icy bodies, each layer fading outward in density and influence. Perhaps the most restful thought is that the Oort cloud exists as part of the solar system, even though it remains unseen. It is a region that does not need to be visible to be real. Its presence is felt through the calm evidence of comet paths and orbital patterns, showing that the universe often reveals itself quietly, through subtle traces rather than obvious displays, and that some of the most important structures are the ones that remain in the background, patiently holding their place. One of the calmest qualities of the Oort cloud is how it represents a kind of slow outer stillness that surrounds everything familiar. It does not sit like a bright landmark in the sky. It exists as a quiet idea supported by patient evidence, reminding us that the solar system includes distant regions that do not announce themselves. The Oort cloud feels like the sun's most distant exhale, a gentle fading of influence into darkness. If you could drift alongside an Oort cloud object, the surrounding space would feel enormous and undisturbed. The nearest icy body might be so far away that it could never be seen with the naked eye. This means the environment would not feel busy or cluttered. It would feel open and calm, like floating in a wide ocean of blackness, where the only visible motion is your own slow passage through space. The way gravity works out there is especially gentle. The sun still holds these bodies but loosely, like a soft thread connecting them to the inner solar system. Because the pull is so weak, tiny influences can matter. A distant star passing through the galaxy can slightly tug an orbit, or the slow tidal effect of the Milky Way can reshape paths over time. These influences act slowly, like careful hands making small adjustments, never hurried, never harsh. The Oort cloud also suggests that our solar system has a quiet outer structure that travels with the sun as it moves around the Milky Way. The sun is not standing still. It orbits the galaxy, carrying its planets, belts, and distant cloud along with it. This means the Oort Cloud is like a moving halo, drifting gently through the galaxy, as if our solar system is wrapped in a soft, distant layer of frozen objects that follow along patiently. Another soothing detail is that long-period comets may spend almost their entire existence far away, never becoming bright, never interacting with planets, never warming up. They remain quiet and dark until something slowly changes their orbit. Even then, the journey inward is long. The comet drifts for thousands of years before it reaches the inner solar system, showing that even the rare moments of activity in our sky begin with immense patience in deep space. Some Oort Cloud objects may be so stable in their orbits that they remain undisturbed for the entire lifetime of the Sun. This means there could be icy bodies out there that have been quietly circling since the solar system formed, and will continue doing so long after Earth has changed beyond recognition. This idea is peaceful because it places us inside a universe where some things are steady beyond imagination, continuing without interruption. The chemistry of Oort Cloud objects is likely preserved in a way that feels almost like frozen history. In the deep cold, volatile compounds remain locked in place. Water ice, methane ice, ammonia, ice, and other materials stay stable, unchanging. These bodies become quiet time capsules, keeping ancient mixtures of solar system ingredients intact, not because they are protected by walls, but because cold and distance create natural preservation. The Oort Cloud also teaches a calm lesson about boundaries. It is not a hard edge where the solar system stops. It is more like a gradual fading, where gravitational influence becomes weaker and objects become less tightly held. This gentle fading means the solar system ends softly, blending outward into the greater galaxy without a dramatic border. That softness makes the universe feel more natural and less abrupt. Even in such darkness, the sky in the Oort Cloud would not feel empty. The Milky Way would stretch across the sky as a luminous band, and distant galaxies might appear as faint smudges of light. With the Sun reduced to a bright star rather than a glowing disk, the wider universe would feel more present. This view would be calming, because it would remind you that even in deep solar system distance, you're surrounded by quiet cosmic structure. Perhaps the most restful part of the Oort Cloud is that it represents how the solar system holds space for stillness. Not everything is a planet with weather and seasons. Not everything is a moon with shifting shadows. Some regions are built for quiet storage, for slow drifting, for long patience. The Oort Cloud is one of those regions, a far icy halo where time stretches wide, motion becomes gentle, and change arrives only when the universe softly decides to nudge something into a new path. One of the most soothing things about the Oort Cloud is that it exists in a region where the universe feels almost paused, not because time stops, but because change becomes so rare that it loses its usual meaning. In the inner solar system, movement is obvious. Planets rise and set, moons shift, seasons turn. In the Oort Cloud, motion is so slow and distances are so wide that the sense of constant activity fades, leaving behind a quiet, steady stillness. The objects in the Oort Cloud are believed to follow orbits that are not neatly aligned like the planets. Many of them may travel on tilted paths, coming in from angles that feel unpredictable from our perspective. Yet out there, it is not chaotic, it is simply spacious. In such a vast sphere, there is room for every direction to exist peacefully, and the idea of up or down becomes less important than the quiet reality of drifting in all directions at once. A calm scientific detail is that Oort Cloud objects may be gently influenced by the slow movement of our solar system through different regions of the Milky Way. As the Sun travels around the galaxy, it passes through environments where the density of nearby stars changes slightly, and where gravitational tides subtly vary. These changes do not create sudden events, they unfold over millions of years, like a slow background shift, reminding us that the solar system's outermost halo is quietly shaped by the galaxy's steady presence. The Oort Cloud also offers a peaceful way to understand comets as travelers rather than intruders. When a comet appears in the inner solar system, it can seem sudden to us. But from the comet's point of view, it has been drifting for thousands of years toward that moment. Its journey began long ago, in darkness, with a tiny orbital change. This long preparation makes the comet's arrival feel less like an interruption and more like a patient return. The cold in the Oort Cloud is more than just low temperature. It is a stabilizing environment. In extreme cold, materials remain solid and quiet. Molecules do not move quickly. Chemical processes slow down. This creates a region where the passage of time leaves fewer marks, where objects can remain physically and chemically stable for billions of years, simply because nothing encourages them to change. Even though the Oort Cloud is distant, it is still part of the solar system's story. It reflects the early era when giant planets shaped the arrangement of smaller bodies. Some objects were scattered outward and lost. Others remained loosely bound and became part of this distant sphere. This history feels calm because it shows that the solar system's outer stillness may have been created gradually through gentle gravitational outcomes rather than a single dramatic event. There is a quiet beauty in the fact that the Oort Cloud is mostly invisible to us, yet still meaningful. We know it through subtle evidence and careful reasoning. That makes it feel like a background structure the universe does not show directly, but allows us to sense through patterns. It reminds us that not everything important is bright or easy to see. Some of the most significant parts of reality remain hidden, existing peacefully without needing attention. If you could travel within the Oort Cloud, you might notice that the sun's position in the sky would barely change over a lifetime. It would remain a bright star fixed among countless others, while your movement would be too slow to create noticeable shifts. This stillness of perspective creates a calming feeling of permanence, where the sky feels steady and unchanging, supporting deep quiet. The Oort Cloud also invites the idea that the solar system's edge is not defined by planets, but by influence. The farther you go, the quieter the sun becomes. Gravity weakens, sunlight fades, and space becomes more open. This gradual decline feels soothing because it shows that the solar system does not stop abruptly. It fades softly, giving way to the galaxy in a gentle transition. Perhaps the most restful thought is that, for most of its existence, an Oort Cloud object experiences no strong events at all. It drifts, it rotates slowly, it remains frozen, and it continues along its wide orbit through darkness. Nothing interrupts it. Nothing demands change. It simply exists in a calm, distant state, part of a quiet halo that surrounds our solar system like a soft boundary of patience and deep time. One of the most peaceful ways to think about the Oort Cloud is as the solar system's most distant form of quiet order. Even though it is spread out and spherical, it is not random. Each icy body follows an orbit shaped by gravity, time, and subtle influences that unfold slowly. This means the Oort Cloud is not a chaotic swarm, but a calm region where motion is guided gently, like a slow dance that continues without urgency. A comforting detail is that the Oort Cloud exists so far away that it feels almost separate from the idea of daily life in space. Closer to the sun, planets and moons create patterns, cycles, and regular changes. In the Oort Cloud, there is no familiar rhythm. Instead, there is continuity. The cold remains steady, the darkness remains gentle, and the motion remains so slow that it blends into stillness. The Oort Cloud reminds us that gravity can be soft. At those distances, the sun still holds these objects, but the pull is light enough that it allows long, wide orbits. These orbits are not tight and fast. They're enormous and slow, taking hundreds of thousands or millions of years to complete. This creates a sense of calm patience, where the solar system's farthest members move in a way that feels almost timeless. Passing stars influence the Oort Cloud in the gentlest possible way. When a star drifts through the galaxy and passes relatively nearby, it does not disturb the Oort Cloud suddenly. Its gravity acts over a long period, gently altering some orbits. The interaction feels like a soft background adjustment, not an event, showing that even external influences arrive slowly in deep space. Galactic tides also act like a quiet current. The Milky Way's gravity, spread across unimaginable scales, nudges the outer solar system in subtle ways. Over millions of years, this can change the orientation of some comet orbits, guiding a few inward. This influence does not create urgency, it creates gradual possibility, like a slow shifting of currents in a very deep ocean. Another soothing idea is that many objects in the Oort cloud may never leave it. They may remain in their distant orbits for the entire lifetime of the Sun, never drifting inward, never being disturbed, never becoming visible. They will simply continue to exist quietly, surrounded by cold darkness and open space, as stable and patient as the outer solar system itself. The chemistry of Oort cloud objects is likely preserved in a way that feels almost delicate. In the deep cold, frozen compounds remain locked in place, protected by low temperatures and minimal sunlight. These bodies may contain materials that formed before the planets fully settled, offering a calm reminder that the outer solar system holds ancient ingredients in a state of long-term rest. From a human perspective, the Oort cloud feels mysterious because it cannot be seen directly. But this mystery is gentle rather than unsettling. It is the kind of mystery that comes from distance and quietness, not danger. It teaches that there are regions of reality that remain beyond our view, yet still exist calmly and consistently, revealing themselves only through slow patterns. The Oort cloud also offers a quiet way to define the outer boundary of the Sun's influence. As you drift outward, sunlight becomes faint, gravity becomes delicate, and the solar system begins to blend into interstellar space. This blending is not abrupt, it is gradual. That gentleness makes the universe feel softer, as though even endings are patient transitions rather than sharp edges. Perhaps the most restful truth is that the Oort cloud represents time stored as distance. It is a region where objects drift so slowly that millions of years pass like moments, where ice remains unchanged, and where the solar system's earliest materials can rest without disturbance. It continues quietly around our Sun, far beyond the planets, holding a calm halo of frozen travelers that remain part of our cosmic home, while the universe beyond stretches outward into even deeper space. One of the most calming aspects of the Oort cloud is how it exists as a reminder that the solar system does not end where things are bright. It ends where things become quiet. Far beyond the last planet, the Oort cloud represents a slow fading of activity into stillness, where the Sun's influence is gentle enough that objects can drift without feeling pulled tightly into motion. It feels like the solar system's softest boundary, made not of walls, but of distance. The objects in the Oort cloud may be so lightly bound to the Sun that their orbits are shaped by the calm presence of the galaxy as much as by the Sun itself. This means the Oort cloud is not only part of the solar system, but also part of the Milky Way's larger gravitational flow. The galaxy's influence arrives like a quiet tide, slowly shifting orbital angles and distances over immense spans of time, guiding motion without urgency. A soothing scientific idea is that the Oort cloud may contain bodies that have never been warmed by sunlight since the earliest days of the solar system. If an object was scattered outward early and then settled into a distant orbit, it may have spent billions of years in constant cold. This creates a sense of preservation so complete that the object becomes like a frozen memory, holding ancient chemistry in a stable form that does not rush toward change. The Oort cloud also invites the thought that many comets are not wanderers by nature, but residents of calm distance. They are not constantly travelling toward the Sun. Most are resting far away, moving in wide, slow paths that keep them in darkness for nearly all their existence. When one eventually appears in our inner sky, it is not a sudden arrival. It is the quiet result of a long, patient drift. Because the Oort cloud is imagined as a sphere, it provides a peaceful explanation for why long-period comets can arrive from any direction. They are not constrained to the flat plane of planetary orbits. Instead, they emerge from above or below, from angled paths that feel like visitors from a quiet surround shell. This spherical distribution adds a sense of completeness, as though the solar system is gently enclosed by distant icy travellers in every direction. The spacing between objects in the Oort cloud may be so large that even if you were floating beside one, you might never see another nearby body. This extreme separation means the dominant experience of the region is open space. The emptiness is not harsh. It is spacious and calm, allowing the mind to rest in the idea of distance without pressure. The low-energy environment of the Oort cloud makes it one of the most stable places for small bodies to persist. Without strong radiation, without frequent collisions, and without rapid thermal changes, surfaces can remain undisturbed. This stability is a kind of natural stillness, where physical conditions encourage quiet endurance rather than activity. A gentle influence on Oort cloud objects comes from the rare passing of nearby stars over millions of years. These stars do not rush by. They drift through the galaxy on their own long paths, and when one comes close enough, its gravity can softly shift the orbit of a distant icy body. The nudge is small, but over time it can change trajectories, showing how the universe can reshape motion through subtle, patient touches rather than dramatic forces. The Oort cloud also reflects the history of the giant planets. Early in the solar system's formation, Jupiter and Saturn in particular had strong gravitational influence, scattering objects outward. Many were lost, but some remained loosely attached to the Sun, settling into distant orbits. This history is calming because it suggests the Oort cloud is not an accident. It is the quiet outcome of long-term gravitational shaping. Perhaps the most restful thought is that the Oort cloud is always there, even when we do not think about it. It surrounds our solar system silently, a distant halo of frozen bodies and open space. It does not demand attention. It does not create constant change. It simply continues, holding a calm outer layer around the Sun, where time stretches wide and motion remains slow, steady, and unhurried. One of the most soothing ideas about the Oort cloud is that it represents a part of the solar system where nothing needs to hurry. In the inner solar system, everything is defined by cycles. Orbits repeat, days pass, seasons shift, and light changes constantly. In the Oort cloud, those rhythms become almost meaningless. Motion continues, but so slowly that it feels like a quiet background truth rather than an active experience. The Oort cloud likely holds objects that are so distant they experience the Sun as a steady bright point, not as a warming presence. The sunlight there is faint and gentle, giving almost no energy to heat surfaces or drive any kind of activity. This means the environment stays stable, cold and calm, allowing icy bodies to remain preserved, as if placed carefully into long-term storage by distance itself. A peaceful scientific detail is that many Oort cloud objects may have surfaces that have not been disturbed for billions of years. With collisions so rare and energy so low, there may be places where dust layers have settled and remained untouched, slowly altered only by faint cosmic radiation. This slow, gentle aging creates surfaces that are quiet records of time, changing so gradually that nothing feels dramatic. The Oort cloud also shows that gravity can hold something without controlling it. These icy bodies are part of the Sun's system, yet the grip of gravity is light. Objects drift in long orbits, sometimes tilted in every direction, and small influences can adjust them slowly. This balance between connection and freedom feels calming, like being held gently without pressure. The galactic environment around the Oort cloud is not empty. The solar system is moving through the Milky Way, surrounded by distant stars, faint gas, and the subtle structure of the galaxy's gravity. Over long timescales, the galaxy's pull can shift Oort cloud orbits slightly. This influence is steady and quiet, more like a soft current than a force, reminding us that our solar system exists inside a larger calm structure. Long-period comets from the Oort cloud are often called visitors, but their journeys are the slowest kind of travel. A comet might spend millions of years circling far away, then be nudged slightly into a path that brings it inward. Even then, it takes thousands of years to approach the Sun. This means the comet's arrival is not sudden in cosmic terms. It is the final part of a journey that began with a tiny change long ago. Another comforting thought is that many objects in the Oort cloud may never be disturbed at all. They may remain in stable, distant orbits throughout the Sun's lifetime, never drifting inward, never becoming visible. They simply exist in their cold quietness, drifting as part of the solar system's farthest halo, holding steady beyond our awareness. Because the Oort cloud is spherical, it surrounds the solar system in a way that feels complete. The planets orbit in a flat disk, but the Oort cloud wraps around that disk like a distant shell. This shape gives a sense of gentle enclosure, as though the solar system is resting inside a wide, quiet sphere of frozen bodies and open space. The extreme cold of the Oort cloud makes it a place where chemistry remains preserved. Volatile substances that would evaporate closer to the Sun remain frozen and stable. Water ice stays solid. Methane and ammonia remain locked into surfaces. This frozen stability makes the Oort cloud feel like a slow chemical archive, where the ingredients of early solar system formation remain stored in peace. Perhaps the most restful detail is that the Oort cloud demonstrates how the solar system fades outward softly. There is no sharp boundary, no wall, and no sudden end. Instead, the Sun's influence gradually weakens, objects become more loosely bound, and space becomes more open. The solar system transitions gently into the galaxy, and the Oort cloud exists within that transition, continuing quietly as the calm outer presence of our cosmic home. One of the most calming things about the Oort cloud is that it exists in a region where the solar system feels more like an idea than a place. The farther outward you drift, the less the familiar structures matter. Planets fall behind, sunlight weakens, and distance becomes the main environment. In that quiet space, the Oort cloud feels like the solar system's soft outer breath, where presence is measured not by brightness, but by gentle gravitational connection. The objects believed to live in the Oort cloud are not arranged in neat lines or clustered crowds. They're scattered through a vast three-dimensional volume, separated by such enormous distances that the emptiness between them becomes the dominant experience. This wide spacing gives the region a peaceful quality, like a quiet landscape where nothing interrupts the stillness and where every object has room to exist without pressure. At those great distances, the Sun becomes a steady point of light that does not strongly change the environment. Sunlight is too faint to create warmth or to drive energetic activity. This means that the Oort cloud rests in a stable cold that does not fluctuate much. The calmness of this stability is that it allows matter to remain preserved, almost like it has been gently placed in a deep freeze that lasts for billions of years. A soothing detail is that the Oort cloud is shaped not only by the Sun, but also by the subtle gravitational presence of the Milky Way. Galactic tides can slowly alter the orbits of distant objects, shifting them over millions of years. These tides do not produce sudden movement. They act like a slow current in a calm sea, guiding motion without haste, reminding us that our solar system is quietly woven into the larger galaxy. Passing stars also influence the Oort cloud in a gentle and patient way. A star drifting through the galaxy might pass close enough over cosmic distances to slightly tug at the orbit of a distant icy body. Even then, the interaction unfolds slowly and softly. It does not feel like disturbance. It feels like a quiet adjustment, as though the universe is reshaping pathways with the lightest touch. The Oort cloud offers a peaceful explanation for why long-period comets appear from unexpected directions. Because the cloud is imagined as a sphere, comets can fall inward from above or below the plane of the planets, yet most of the comets remain far away, never travelling inward at all. This means the Oort cloud is mostly a place of stillness, with occasional slow journeys that begin only rarely. the chemistry of Oort Cloud objects is likely preserved in its most stable form. Frozen compounds remain locked in place, protected by cold darkness. Water ice, methane ice, ammonia ice, and complex carbon-based molecules can remain unchanged for immense spans of time. This makes the Oort Cloud feel like a calm archive of ancient material, holding the early ingredients of the solar system quietly in storage. In the Oort Cloud, the concept of weather disappears. There are no winds, no storms, no clouds of vapor rising and falling. Surfaces remain calm, shaped mainly by slow accumulation of dust and the faint aging effects of radiation. This absence of atmosphere-driven change creates an environment where stillness is the natural state and where time leaves only the softest marks. The vast emptiness of the Oort Cloud can feel comforting because it removes urgency. Nothing is close enough to force interaction. Nothing moves fast enough to feel sudden. Space becomes wide and patient, allowing the mind to rest in the idea of distance without expecting anything to happen quickly. Perhaps the most restful thought is that the Oort Cloud represents the solar system's quiet outer memory. It may contain bodies that were scattered outward during the earliest era of planet formation and have remained there ever since. These objects have drifted through deep time in cold darkness, held gently by gravity and influenced softly by the galaxy, continuing quietly as a distant, calm halo around our sun. One of the most soothing ways to imagine the Oort Cloud is as the place where the solar system becomes truly quiet. Not quiet in the sense of silence alone, but quiet in the sense that almost nothing changes. The farther you drift outward, the less the sun can reshape the environment. Light fades, warmth disappears, and motion becomes so slow that even movement feels like stillness. In that calm, the Oort Cloud feels like a gentle outer layer where the solar system rests. The bodies believed to inhabit the Oort Cloud are spread across such huge distances that their numbers do not create busyness. Even if there are trillions of objects, the space between them is so vast that the emptiness dominates everything. This makes the region feel peaceful and open, like a wide landscape with no crowds, where every object exists alone in a quiet pocket of space. At such extreme distances, the sun's gravity still holds these objects, but only lightly. It is not the strong pull that shapes planetary orbits. It is a delicate connection that allows objects to remain bound, while also being sensitive to subtle influences. This balance between being held and being free creates a calming feeling, like a gentle hand resting without gripping. A peaceful detail is that the orbits of Oort Cloud objects may be enormous, stretching across distances that take hundreds of thousands or millions of years to complete. This means that if you were to watch the sky from near one of these objects, you would not notice motion in any meaningful way. The sun would appear almost fixed among distant stars, and the object's journey would unfold too slowly to be felt, creating a sense of deep steadiness. The Oort Cloud also exists in a region where the Milky Way's presence becomes more noticeable. Galactic tides slowly influence these distant objects, reshaping orbits over immense spans of time. This influence is not harsh or dramatic. It is steady and gentle, like a slow ocean current moving beneath a calm surface, guiding motion quietly in the background. Passing stars are another soft influence on the Oort Cloud. Over millions of years, stars drift through the galaxy, and occasionally one passes close enough, in cosmic terms, to nudge the orbit of a distant icy body. The nudge is small, the response is slow, nothing happens suddenly. It is an interaction that feels patient, as though the universe is making adjustments through calm, gradual touch. The extreme cold of the Oort Cloud creates a stable environment where surfaces can remain preserved for billions of years. Without sunlight to warm them, without atmosphere to reshape them, and without frequent collisions, icy layers remain frozen and quiet. This preservation makes the Oort Cloud feel like an archive of the solar system's earliest materials, held safely in darkness by the natural stillness of deep space. Another calming part of the Oort Cloud is that it helps explain the rare appearance of long-period comets. These comets may spend nearly all their existence far away in cold darkness, drifting gently in wide orbits. Only once in a very long while does a subtle gravitational influence shift their path inward. Their travel to the inner solar system then takes thousands of years, making their appearance less like a sudden event and more like a slow return. The Oort Cloud reminds us that boundaries in nature are often gentle transitions rather than sharp edges. The solar system does not end with a clear line. It fades gradually outward, becoming less dense, less influenced by the sun, and more connected to interstellar space. This softness makes the universe feel calmer, as though even endings are slow and patient. Perhaps the most restful thought is that many Oort Cloud objects may never be disturbed at all. They may remain in their distant orbits for the entire lifetime of the sun, never drifting inward, never becoming visible. They simply continue, quietly and steadily, part of a distant halo that surrounds our solar system like a soft, frozen boundary of deep time and calm space. One of the most relaxing things about the Oort Cloud is that it exists in a place where the solar system becomes more like a quiet thought than a physical environment. Out there, everything familiar fades. The planets are far behind. The sun's warmth is gone. Even sunlight becomes so faint that it feels like a soft, distant glow. In that stillness, the Oort Cloud feels like the calm outer dream of our solar system, where distance itself becomes the main feature. The Oort Cloud objects are believed to be spread so widely that even the concept of neighbours loses meaning. If you were beside one icy body, the next might be so far away that it could not be seen, even though it exists. This kind of separation creates a peaceful atmosphere where nothing crowds anything else, and where every object seems to have endless space to drift within. At these distances, gravity acts with gentle patience. The sun still holds the Oort Cloud loosely, but the pull is delicate. This means the orbits of these objects can be softly adjusted by tiny influences. A slight galactic tide or the subtle passage of a distant star may reshape a path over millions of years. It is a calm kind of motion, guided slowly, never forced and never rushed. A soothing detail about Oort Cloud objects is that their surfaces may contain frozen mixtures that have not changed since the beginning of the solar system. Water ice, methane, ammonia, carbon dioxide, and complex organic compounds may be locked into place by cold darkness. There is no strong sunlight to rearrange them, no atmosphere to weather them, and no heat to disturb them. In this way, each object can remain like a frozen page of ancient history, preserved naturally by the quiet environment. The Oort Cloud offers one of the gentlest explanations for long-period comets. These comets do not wander constantly. They rest. For millions of years they remain far away, drifting slowly in wide orbits. When one finally appears in the inner solar system, it is the result of a tiny orbital change that began long ago, making the comet's arrival feel like a slow unfolding rather than an interruption. The Milky Way's gravity shapes the Oort Cloud in a way that feels almost like breathing. Galactic tides act slowly and steadily, nudging the most distant objects in subtle ways. Over deep time, these tides can change orbital angles, gently guiding some bodies into paths that bring them closer to the sun. The motion is delicate and gradual, as if the galaxy is softly touching the solar system's outer edge. Passing stars also influence this region, but their influence arrives gently. A star may pass through the galaxy and come near enough to shift a few distant orbits slightly. Yet even this happens over huge distances and long durations. The interaction feels like a quiet gravitational whisper, shaping motion slowly rather than disturbing it suddenly. The Oort Cloud reminds us that space can be calm not because it is empty, but because it is spacious. Even if billions or trillions of objects exist there, the space between them remains enormous. This space prevents urgency. It prevents collision. It allows everything to drift quietly, free from frequent interaction. The emptiness becomes a form of comfort, like an open room that never feels crowded. Another restful perspective is that the Oort Cloud creates a soft boundary between the solar system and interstellar space. There is no clear ending. the density of objects gradually decreases, the sun's pull weakens further, and the region blends outward into the wider galaxy. This transition is gentle, and it makes the universe feel less sharp, as though even the edges of a star system are made of slow fading rather than abrupt stopping. Perhaps the most peaceful thought of all is that the Oort cloud continues whether or not it is seen. It does not need visibility to exist. It surrounds us quietly, a distant halo of frozen bodies drifting through darkness. It holds deep time in its orbits and deep stillness in its cold. It remains part of our cosmic home, resting patiently at the far edge of the sun's gentle reach. One of the most calming truths about the Oort cloud is that it represents a place where the solar system becomes almost weightless in its presence. Not because gravity disappears, but because gravity becomes gentle enough to feel like a quiet suggestion rather than a strong force. Out there, the sun still matters, but in a softened way. It is an anchor seen from an incredible distance, holding icy objects in slow motion as if time itself has been stretched into calmness. The objects in the Oort cloud are believed to be scattered so widely that they form a region defined more by emptiness than by matter. Even if trillions of icy bodies exist there, the typical distance between one and another could be so large that you might drift for years and never pass close to anything at all. This spacing creates a peaceful feeling of openness, where space dominates everything and nothing interrupts the stillness. At those extreme distances, the sun's light becomes faint and quiet. It does not create a bright day. It does not cast strong shadows. It barely warms surfaces. Instead, it becomes a soft point of illumination, like a distant lamp seen from far down a hallway. This gentle light contributes to the Oort cloud's sense of calm because nothing is harsh or intense. Even brightness becomes soft and minimal. A soothing scientific idea is that the Oort cloud may contain bodies that were once part of the solar system's early building material. In the chaotic but slowly settling era of planet formation, many small icy objects were scattered outward. Some were lost entirely, but others remained loosely connected to the sun. Over time, these survivors may have become part of the Oort cloud, not through sudden placement, but through a gradual settling into long, distant orbits. Galactic tides continue to influence the Oort cloud like a slow, steady rhythm. The Milky Way's gravitational field stretches across vast distances, and at the edge of the solar system, that influence becomes noticeable. Over millions of years, the galaxy's gentle pull can shift orbital orientations and subtly guide objects into new paths. It does not feel like a forceful event. It feels like a quiet background current, always present, always patient. Passing stars also offer faint, gentle interactions. A star moving through the Milky Way might pass near enough, over cosmic distances, to slightly tug on some Oort cloud objects. This tug is small and slow. It may only adjust an orbit a little, but over deep time even a little adjustment can matter. The comforting part is that these influences act softly, never rushing, allowing the Oort cloud to remain stable most of the time. The Oort cloud gives a peaceful explanation for why some comets arrive from far outside the plane of the planets. Because this distant region is spherical rather than flat, comets can approach from above, below, or from angles that feel surprising. Yet these arrivals are rare. Most objects remain far away, continuing their quiet drift. The cloud is a place of rest first, and of motion only occasionally. In the cold of the Oort cloud, frozen compounds remain stable. Water ice stays solid. Methane and ammonia remain locked into surfaces. Chemical activity slows to near stillness. This means that an Oort cloud object can preserve ancient materials for billions of years, serving as a calm archive of the solar system's earliest chemistry. It is like a deep freeze created by nature, storing ingredients in silence. The Oort cloud also reminds us that the solar system's boundary is not a sharp line. It fades outward. The farther you go, the weaker the sun becomes, and the more space feels like the wider galaxy. The Oort cloud exists within that fading zone, acting as a soft transitional region. This gradual blending makes the universe feel gentle, as though it prefers smooth transitions rather than abrupt endings. Perhaps the most restful detail is that many Oort Cloud objects may never travel inward at all. They will remain in distant orbits for the entire lifetime of the Sun, never becoming bright, never becoming visible, never leaving their cold, quiet home. They will simply continue, drifting slowly through darkness, held lightly by gravity, surrounded by open space, existing in the calmest outer layer of our solar system. One of the most soothing ways to understand the Oort Cloud is as the solar system's slowest and most distant form of belonging. It is far enough away that the Sun no longer feels like a warm centre, yet the cloud still remains connected to the Sun's gravity, held gently in place. That combination of distance and connection makes the Oort Cloud feel like a calm outer embrace, where objects are free to drift, yet never completely detached from home. The Oort Cloud exists in a region where movement becomes so slow that it feels almost like stillness. If an icy body takes hundreds of thousands or millions of years to complete an orbit, then motion is no longer something you observe in moments. It becomes a quiet truth that exists in the background, like the slow turning of something vast and ancient, happening without urgency and without sound. Because objects are so widely spaced, the Oort Cloud is not a crowded region, even if it holds enormous numbers of bodies. Space dominates the experience. The emptiness between objects is vast, calm, and open, creating an environment that feels gentle rather than lonely. Nothing presses in, nothing interrupts. Everything has room to exist without friction. At such extreme distances, sunlight becomes faint enough that it cannot shape the environment the way it does closer to the Sun. There are no cycles of heating and cooling, no melting, no evaporation. Instead, the cold remains steady. Surfaces stay frozen. The entire region rests in a stable temperature that encourages preservation, making the Oort Cloud feel like a natural deep freeze created by distance itself. A peaceful scientific detail is that the Oort Cloud is influenced not only by the Sun, but also by the larger gravitational structure of the Milky Way. Galactic tides gently reshape the orbits of distant objects over millions of years. This influence is subtle and constant, acting like a slow current that never becomes a wave. It reminds us that our solar system is part of something larger, and that even its farthest edges are quietly shaped by the galaxy's steady presence. Passing stars can also affect the Oort Cloud, but their influence arrives with patience. Stars drift through the galaxy over long timescales, and when one passes near enough, it may slightly tug on distant orbits. This tug does not create chaos, it creates gentle change, shifting a trajectory little by little, showing that even outside influences in space often arrive as soft adjustments rather than disruptions. The Oort Cloud helps explain long-period comets in a way that feels calming because it turns sudden appearance into slow history. When a comet enters the inner solar system, it may seem sudden to us, but it is actually the result of a journey that began long ago. A tiny orbital nudge, perhaps millions of years in the past, slowly guided the comet inward. Even then, the travel took thousands of years, making the comet's arrival feel less like an event and more like the final step of a patient drift. The chemistry stored within Oort Cloud objects may be some of the oldest preserved material in the solar system. Frozen water, methane, ammonia, carbon dioxide, and complex organic molecules can remain stable for billions of years. These bodies become quiet archives, carrying ancient mixtures that formed when the solar system was young, held in place by cold darkness and minimal change. Another calming part of the Oort Cloud is the way it shows how the solar system fades outward softly. There is no clear edge where everything stops. Instead, the density of objects slowly decreases, the sun's pull grows weaker, and space becomes more open. The Oort Cloud exists within this gradual transition, helping the solar system blend gently into interstellar space without a sharp boundary. Perhaps the most restful thought is that the Oort Cloud is mostly a place of waiting. Not waiting with expectation, but waiting as a natural state. Most objects there will never move inward. They will never become bright comets. They will simply continue along their distant, quiet paths, drifting in cold darkness, surrounded by open space, existing as part of the solar system's calmest and most patient region. One of the most calming qualities of the Oort Cloud is that it feels like the solar system's deepest quiet, a place so distant that even the idea of change becomes soft. Out there, motion still exists, but it is so slow that it blends into stillness. The sun still holds these icy bodies, but gently, like a distant memory of gravity rather than a strong grip. It is a region where everything seems to rest within time rather than move through it. The objects of the Oort Cloud are thought to be scattered through an enormous spherical volume, and that shape gives the solar system a kind of distant completeness. Instead of being limited to the flat disk where planets orbit, the Oort Cloud surrounds the system above and below in every direction. This feels peaceful because it suggests the solar system is wrapped in a soft halo, not a barrier, but a gentle outer layer that fades outward into the wider galaxy. At such distances, sunlight becomes so faint that it no longer shapes surfaces in the way we are used to. There is no warming cycle, no active evaporation, no bright day and dark night. Instead, there is a steady cold and a quiet darkness that remains consistent. This stability creates a restful environment where icy materials can remain unchanged for billions of years, preserved simply because nothing encourages them to transform. A soothing detail is that collisions in the Oort Cloud would be extraordinarily rare. Even if there are trillions of objects, the distances between them are so vast that most will never come close to another body. This means surfaces can remain undisturbed, histories can remain intact, and the region as a whole can exist in a calm state without frequent interruptions. The Oort Cloud is gently shaped by the Milky Way's gravity through something called galactic tides. These tides are not dramatic forces, they are subtle influences that act over millions of years, slowly reshaping the orbits of distant objects. The calmness of this process is that it happens gradually, like a slow current beneath a still surface, guiding motion without urgency. Passing stars can also influence the Oort Cloud, but their effect is patient and light. A star may drift near the solar system over a long period, and its gravity can slightly tug on the paths of distant icy bodies. The tug is small, but over deep time it matters. The interaction feels like a gentle adjustment rather than a disruption, reinforcing the quiet nature of distant space. Long-period comets are connected to the Oort Cloud in a way that feels almost like slow breathing. Most of the time they remain far away, quiet and frozen, drifting in wide orbits. Only once in a very long while does an orbit change enough to guide one inward. Even then, the inward journey is slow, taking thousands of years. This makes the arrival of a comet feel less like a sudden event and more like the universe gradually bringing something closer. The chemistry of Oort Cloud objects is likely preserved in a remarkably stable state. Frozen water, methane, ammonia, and complex organic molecules remain locked into place by cold darkness. This preservation makes each body feel like a quiet archive, storing ancient materials from the early solar system and holding them unchanged for immense spans of time. The Oort Cloud also reminds us that the boundary of the solar system is not sharp. It fades outward, becoming less dense, less influenced by the sun, and more connected to the open galaxy beyond. This gradual fading is peaceful because it shows that the universe often prefers smooth transitions rather than sudden endings. The solar system blends into interstellar space gently, like a quiet dimming of light. Perhaps the most restful thought is that the Oort Cloud continues without needing attention. It surrounds us silently, far beyond the planets, far beyond everyday imagination. Most of its objects will never be seen, never become active, never travel inward. They will simply drift slowly through cold darkness, held lightly by gravity, existing in the calmest outer region of our cosmic home. One of the most peaceful ways to think about the Oort Cloud is as a region where the solar system becomes almost entirely quiet, not because it disappears, but because it softens. The farther you drift outward, the less the sun feels like a powerful center, and the more it feels like a gentle point of connection. In that distant space, the Oort Cloud exists as a calm, fading halo where everything is defined by patience, cold, and slow motion. The objects believed to live in the Oort Cloud may be so widely spaced that the emptiness between them becomes the most important feature. Even if trillions of icy bodies exist there, each one has enormous space around it, with no nearby neighbours, no frequent interactions, and no crowded regions. This wide separation creates a sense of calm openness, like a silent landscape where nothing interrupts stillness. At those distances, sunlight is extremely faint, and its warmth is almost absent. The sun becomes a bright star rather than a glowing disk, and it no longer shapes the environment with energy. There are no strong shadows, no dramatic light shifts, and no warming cycles. This steady faintness makes the Oort Cloud feel visually and physically gentle, a place where light itself has softened. The Oort Cloud is thought to be mostly made of icy bodies similar to comets, containing frozen water and other volatiles like methane, ammonia, and carbon dioxide. In the deep cold, these materials remain stable for immense spans of time. Chemical change slows, physical change slows. This preservation makes the Oort Cloud feel like a quiet archive of the solar system's earliest ingredients, held in a natural deep freeze. A calming detail is that the Oort Cloud is shaped by the quiet influence of the Milky Way. Galactic tides gently adjust the orbits of distant bodies, not quickly, but over millions of years. This influence is subtle, steady, and slow, like a background rhythm that never becomes urgent. It reminds us that the solar system's outermost region is quietly linked to the larger structure of the galaxy. Passing stars can also have a gentle effect. A star drifting through the galaxy might pass near enough, over cosmic distances, to slightly alter the path of an Oort Cloud object. The change is not dramatic. It is a small adjustment that unfolds slowly. Even the idea of disturbance in the Oort Cloud feels calm because everything happens over such long time frames that it blends into quiet continuity. Long-period comets connect the Oort Cloud to the inner solar system in the most patient way possible. These comets spend almost all their lives far away, moving slowly through darkness. When one finally begins to drift inward, it does so over thousands of years. The comet's arrival in the inner solar system is only the final step of a long journey that began as a subtle change long ago. The spherical shape of the Oort Cloud creates a sense of completeness. Unlike the flat plane of planetary orbits, the Oort Cloud surrounds the solar system in every direction. This gives the impression that the solar system is gently wrapped in a distant halo, a quiet shell of icy bodies that marks where the sun's influence fades into the wider galaxy. The Oort Cloud also teaches a restful lesson about boundaries. There is no sharp edge where the solar system ends. Instead, its influence fades gradually. Gravity weakens, objects become more loosely bound, and the region blends outward into interstellar space. This gradual fade feels peaceful because it suggests the universe transitions gently, without abrupt endings. Perhaps the most soothing thought is that the Oort Cloud is mostly a place of rest. Most objects there will never move inward. They will never become bright comets. They will simply remain in their distant orbits, drifting slowly in cold darkness, untouched and unchanged. The Oort Cloud will continue as a calm, invisible halo around the sun, quietly existing in deep time far beyond the planets. One of the most relaxing qualities of the Oort Cloud is that it feels like the solar system's deepest stillness, a place where the universe is not trying to do anything quickly. Out there, nothing is urgent. Motion is slow, light is faint, and time stretches wide. The sun remains present but softly, like a distant anchor that holds the outermost region of our solar system with the gentlest possible gravitational touch. The objects believed to populate the Oort Cloud are so far apart that, even if there are immense numbers of them, the region still feels empty and open. This spaciousness is calming because it removes the sense of crowding or interaction. Each icy body exists quietly within a huge personal space of darkness, drifting without interruption, surrounded by the kind of quiet that comes only from distance. At such extreme ranges, the sun's light becomes so weak that it no longer shapes the environment. There are no cycles of warming and cooling, no sunlight strong enough to melt ice or evaporate surface layers. Instead, the cold remains steady. This stable cold preserves surfaces and chemistry, allowing objects to remain almost unchanged for billions of years, like frozen memories stored safely in deep space. A peaceful scientific detail is that the Oort Cloud is influenced by both the Sun and the Milky Way. Galactic tides act slowly, shifting the orbits of distant bodies over millions of years. These tides do not create sudden change. They move gently and consistently, like a quiet background current that reminds the outer solar system that it exists within a larger galactic structure. Passing stars can also affect the Oort Cloud, but even this influence arrives calmly. Stars travel through the Milky Way on long, patient paths. If one passes near the solar system, its gravity may slightly adjust the orbits of a few distant icy bodies. The changes are small and unfold over long periods, making the entire interaction feel like a soft gravitational whisper rather than a disturbance. The Oort Cloud provides a soothing explanation for long-period comets. These comets do not begin their journeys as sudden visitors, they begin as quiet objects resting far away. Over immense spans of time, subtle influences shift their paths, and slowly, gently, they start drifting inward. Even then, the journey takes thousands of years. Their eventual arrival near the Sun is simply the final part of a long and patient drift. Because the Oort Cloud is spherical, it surrounds the solar system in every direction. This shape feels comforting because it suggests completeness. The planets travel in a flat plane, but the Oort Cloud wraps around that plane like a distant shell, a quiet halo that contains the solar system within a larger soft boundary of icy bodies and open space. The chemistry of Oort Cloud objects may be among the most ancient preserved material in our solar system. Frozen water, methane, ammonia, carbon dioxide, and complex organic molecules remain stable in the cold darkness. This preservation makes the cloud feel like a quiet archive, holding early solar system ingredients untouched, allowing them to rest in their original forms without being reshaped by sunlight or heat. The Oort Cloud also reminds us that the solar system fades outward rather than ending abruptly. There is no line where the sun's influence suddenly stops. Instead, gravity weakens gradually, objects become more loosely bound, and space becomes more open. The solar system blends gently into interstellar space, and the Oort Cloud exists within that quiet transition zone, marking the soft edge of belonging. Perhaps the most restful thought is that most Oort Cloud objects will never be seen, never become active, never travel inward. They will remain in cold darkness for the entire lifetime of the Sun, drifting slowly along distant paths, undisturbed and unchanged. The Oort Cloud will continue quietly around our solar system, a calm halo of frozen bodies where time moves slowly and the universe feels endlessly patient. As this quiet journey through the Oort Cloud continues to settle softly in your mind, there is nothing you need to hold on to and nothing you need to follow. The solar system can remain vast and distant without needing your attention. Far beyond the familiar planets, that gentle halo of frozen bodies will continue drifting in darkness, moving slowly, patiently, and without effort. You may notice your thoughts becoming lighter now, less detailed, like faint starlight spreading out into the background. That is perfectly natural. The Oort Cloud does not rush toward endings, and your mind does not need to reach one either. Everything can stay open, calm, and unfinished in the most peaceful way. Let your breathing remain easy and unforced. Let your body rest exactly where it is, Imagine yourself drifting outward into that deep stillness, where the sun becomes a quiet point of light and the space around you feels endlessly wide. Nothing presses in, nothing demands anything from you. Everything simply continues gently and steadily. The Oort Cloud reminds us that distance can be comforting, that cold can be stable, that silence can be full of presence, not emptiness. In the farthest reaches of our solar system, even time seems to soften, stretching so wide that change becomes slow enough to feel like rest. Thank you for spending this time with the Sleepy Scientist. Whenever the world feels loud or your thoughts feel heavy, you are always welcome to return. The universe will still be here, unfolding quietly, holding its calm structure in place. For now, allow the quiet to remain. Let the darkness feel gentle, let the distance feel safe, and let whatever comes next arrive naturally. Good night.